Okay, 8th grade. This is one of the last topics we'll be talking about. Actually, this is the last topic we'll be talking about for 8th grade science before we do our final lab of the year. And it is about circuits. So a circuit can either be closed or open. And when we say a closed circuit, that means that there's a direct line between the voltage source, which is usually something like a battery or like an outlet. There's a direct line between the voltage source and the end of the voltage source. So it can go directly from the positive terminal to the negative terminal. And it goes through some stuff like it goes through wires, it goes through a light bulb, which is a resistor. Sometimes it'll have a switch. So like a light switch is a perfect example of this, where you turn it off and you don't get this current flow going, but then you turn it on, and so it closes the switch, and you get current flow, as opposed to an open circuit, where the switch is open, or there's some part of the circuit that does not directly connect from the positive terminal to the negative terminal. And so you get no flow of electricity, so your light bulb doesn't turn on. So when you turn off your lights, you are actually opening the switch and thus breaking the connection between positive and negative terminal. There's basically circuit diagrams are ways to draw these different parts in action, so that you don't need to be an artist like over here, where you would have to specify like, oh, this is what the battery looks like, and this is what the light bulb looks like, and this is what the resistor looks like. I'm not even sure what this is, but it's resisting the flow of current. And then here's your switch, like a light switch. So basically, scientists are not artists, and so they made shorthand for circuits. So these two lines over here represent a battery. This represents a light bulb. These squiggle lines represent a resistor. And two dots with a line that can be open or closed represents a switch. And this is just going over some of those again. If in a straight line, just the lines are just wires or things connecting the terminals to each other. And remember, wires don't have very much resistance at all to electricity, and that's because they're really good conductors. So now we have to get into the types of circuits that you can have. There are two types. The first one is called a series circuit, and a series circuit has only one path for the current to flow. The current is the same throughout the entire circuit, but as you continue on, the voltage decreases as it passes through resistors. So a series circuit, you assume that there's at least one resistor. And if any part of the circuit is broken, the circuit fails, and so you get no current flow. So an example of this, if you have some older Christmas lights, they're wired in series. So each light bulb is its own resistor, and they're strung together like one by one. They're in a line. So if one of the bulbs goes out, that means that you have a resistor that has stopped working in this series circuit. And if that happens, then all the bulbs are not going to turn on because it's in series. Because if any part of a series circuit breaks, the circuit fails. So this is what it looks like in a diagram. You have your battery over here, the current flowing, and its light bulbs strung along right next to each other. This is in contrast to a parallel circuit, which can have more than one path for flowing. By definition, it has more than one path for flowing. The branches of a parallel circuit are all independent, so if one of them fails, the rest of them can still work. Voltage and current are the same across the branches, and an example of this would be at home or in school, your devices are wired in parallel, so that if your, let's say one of your light bulbs on your lamp stops working, it doesn't mean everything in your house stops working. It just means that that one thing has stopped working because that resistor shut off. And this is what it looks like in the diagram. So you have your battery, and the current can either choose to go through this light bulb resistor, or it can go the longer way. And it doesn't matter which one is longer or shorter. What actually matters is what the resistance is on each light bulb. Because what will happen is the current will want to go through the path of least resistance. And that kind of brings us to this idea of equivalent resistance. In a series circuit, as you add more resistors, you get more resistance in total. And that makes sense because the resistance is added up together for each resistor along the path. As you go along the path, there's more and more and more. And we can kind of imagine that this string of resistors, so think about your Christmas lights again. You can imagine that all those Christmas lights acting as resistors are just one giant resistor. And the way you could do that is by adding them together like this, where R sub E means equivalent resistance, and you just add up all the resistances together.